Hello, I'm Graham Lewis, and in this video we're going to discuss how to do 3 2/5 minus 2 3/4. And we're going to do it doing two different methods. And the importance of that is to decide which method is best to use and when. And that gets me on to critical thinking. I asked my grade 8 class exactly that question. What is critical thinking? I had some great ideas. Eventually we came across what we believe is a great definition of what is critical thinking. Critical thinking has its origin in the word criteria. That's where the word crit comes from. Critical thinking is actually criteria thinking. We have different options and we decide what is the best option carefully using criteria. So what kind of criteria in mathematics are we looking at? Is it the one we understand more? Is it the fastest? Is it the one where we make least mistakes? They're all criteria for choosing the best approach. So let's have a look at that question now with that lens in mind. What approach is best for this question? So I'm going to do this question two ways, and I'm going to ask you what criteria at the end do you think you would choose for which approach. So I'm going to do it first by using the whole numbers and the proper fractions. So I'm going to express 3 2/5 as 3 2/5. If I was on a number line, that's where I'd go to. I'd go to 3 to the right, and then I'd go 2/5 to the right, and I'd be at 3 2/5. I want to minus 2 3/4. Now this can be confusing for some people, so I'm just going to draw a quick number line just to really explain this. There's minus 2, and there's minus 3. Minus 2 3/4 is roughly there, isn't it? 3/4 of the way through. Now, when you're thinking of minus 2 3/4, you're doing minus 2, and you're also minusing another 3/4. So minus 2 3/4 is minus 2 minus 3/4. So if I'm separating this out, it's minus 2 minus 3/4. Now I'm going to combine, a little bit like algebra with like terms, I'm going to combine the whole numbers because we can add and subtract in any order. So I've got a 3, and let's make sure that I've got that minus 2 attached there. I've got 3 minus 2. 3 minus 2 is 1. I'm just going to write that down. And then I'm going to do the proper fractions, 2/5 minus 3/4. I think we should pause the video now, and you should finish this off, and you should get 13/20. Okay, so I'm going to pause the video. You finish it off. You should get 13/20 if you get it right. I'll go through it, use common denominators. So here we are with common denominators. So clearly I have to write this with a common denominator of 20. So when I'm writing 2/5 and I want it to be out of 20, what I'm actually doing is multiplying by 1. But I'm going to multiply, my 1 is 4 divided by 4, because 4 divided by 4 equals 1. So to keep it equivalent, I'm multiplying by 1, and the 1 I'm choosing is 4 by 4. So people remember the rule, what you times by the top, times by the bottom. True, but what you're really doing is multiplying by 1, but your 1 is a really clever one. It's 4 divided by 4, giving me 8 over 20. 2 times 4 is 8, 5 times 4 is 20. That's a really important idea in mathematics, multiplying by 1. And it's useful all the way through university as well. Often the two biggest tricks are adding 0 and multiplying by 1. So understand that. You're actually multiplying by 4 over 4, which is 1. So I get an 8 over 20. Here, the one I'm multiplying by is, of course, 5 over 5. 4 times 5 is 20, and 3 times 5 is 15. So I end up with 1 minus 7/20. And you can either do that in your head is 13/20, or you can rewrite the 1 as 20/20, because 1 is 20 over 20, minus 7/20, and count how many 20ths you've got. And you've got 13/20. Remember, you haven't got any 13/40. You're not counting 40ths, you're counting 20ths. If you had 20 dogs and you minus 7 dogs, you'd have 13 dogs. Here I'm counting not dogs, but 20ths. Okay, so that's method 1. So let's have a think what we like about that method. All right, I'm not going to answer that. You're going to think about what you like about that method, how you would kind of rate that method as a method. Now let's do the question a different way. I'm now going to do it using improper fractions, or top-heavy fractions as I call them. Okay, so a student in class, I said to a student today in class, can we write this as an improper fraction? And a student replied, yeah, it's 17 over 5. And I said, why? And he said, because 5 times 3 add 2 is 17. I said, why? And they said, because that's the rule. And I said, well, why does it work? And they ultimately replied, because a teacher many years ago told them the rule. And so I just don't get it. So then another student said, well, it's because you've got 5 kind of like groups of 3. So you've got 15 thirds. I said, oh, so you can rewrite, if I'm looking at 3 and 2/5, you can rewrite the 3 as 15 fifths, and then I've got the 2/5. Now I get it. You do 5 times 3 because that's your 15. That's how many fifths you've got. And then you add the 2 because that's what you're doing. You've got 15 fifths, add 2/5. You've got 17 fifths. Brilliant. Okay, so now I understand the rule. It's really important in maths, not just to learn rules. You need to actually understand them. Otherwise, you forget the rule, you can't do anything. And understanding mathematics is when you're able to apply it. So always question your teachers. Why? Make sure you understand the rules. Same way, 2 is 8 quarters. So I've got 8 quarters plus 3 quarters. So I've got minus 11 quarters. Now I can use common denominator. So I'm going to have 20 again as my common denominator. Here, I've multiplied the bottom by 4. I'm going to multiply the top by 4. 17 times 4 is 68. Here, I'm multiplying top and bottom by 5, which is effectively 1, why it stays the same. So 11 times 5 is 55. And I end up with 68 20ths minus 15 20ths. Same answer as last time, 13 20ths. So now's the time to think which method you prefer. Do you prefer this method? Or do you prefer the first method? Yeah. They both give the right answer. So which method do you prefer? And what criteria are you using to base your decision? Would a different question be better with one method or another method? And that's it from me. So in my opinion, I would choose this method for this question because these numbers were not too big for me and I didn't find them hard. If you find these numbers hard, then you should use the top method, maybe. But I found this shorter and quicker and easier for me. So my criteria was shorter, easier and quicker for me for this question. In terms of this question, I found it longer and less efficient. But the numbers were smaller, 8 and 15. As opposed to 68 and 55s. So if you're finding the big numbers hard, you would choose the first method. My dream for you, if your answer was actually I like method 2 because I understand it more, my dream for you is to understand both methods equally well and be comfortable with them. And you can with practice. I mean, I'm sure you realize that I find both of them equally easy. I would like you to find both methods equally easy, and then you can have good criteria to choose between them. And that's what the best mathematicians do. They look at a problem, have multiple ways to do it, and choose, based on criteria, the best way to do it. Thank you very much, everyone. Critical thinking, so important in mathematics. Have a great day.